Okay, this is test corrections for Algebra 2. And this first problem here, basically where we're looking at a seating situation and we want to analyze each one of these. It says analyze each design. Well, first look at the side viewing area right here. This side viewing area, basically is just adding 2 every time. So you can see it right here. All it does is add 2. And so basically that's just going to be a +2 in your pattern. Now if you look at the front viewing area right here, the front, we can see if this is design 1, well, this is 1 squared, design 2 is 2 squared, and design 3 is 3 squared. So basically it's our design number squared. And last, if we look at our performance area, what's happening here is if our design is 1 here and we have 2, and design is 2 and we have 4, design is 3, we have 6, basically what we're doing here is a times 2 each time. And so if we look at our design, 1 times 2 is 2, design 2 times 2 is 4, 2 times 3 is 6. So the performance area is basically our design times 2. So 2 times the design. And that's the basic analysis of this. So if I were to sketch the one for the 4th design, I'd basically just put 4 across the top. So 1, 2, 3, 4. And then a second row, 1, 2, 3, 4. I'm going to add 2 on the sides. This is our side viewing area. And then here in the bottom, I'm going to go 4 by 4. Because the pattern is, whatever my design is, I have a square down here with the number of blocks that equals our design. So this would be basically our seating area for 4. Now a city oh, sorry, I didn't have that in the camera. Here it is here, I'm sorry, here we go. So 2 rows of 4 here, because we have 2 rows, plus 2, and then our 4 square. Okay, so moving on to this next pattern here. The city wants to build an auditorium with 50 block sections for the 2 viewing areas. So we only want to look right here at the viewing areas. And the viewing areas are d squared plus 2. Okay? So if we're looking at the viewing, our side view area is a plus 2. And our front view area is d squared, d times itself. And so if basically they want a max of 50, this has to be less than 50. Because that's the highest we can get. So if we use a little algebra, we could subtract 2 from both sides here. And so now we have a 48 and d squared. And so our question is, what number squared is less than 48? Well, if I take the square root of both sides, the square root of 48, I'm going to have to plug that in the calculator because I don't have all this memorized, so I'm going to plug this in the calculator. So let's clear this out. And I'll do a square root of 48 here, okay? And that says 6.9. So it's 6.9, but I can't put, if I put a 7 in here, it's 49, so it's too high. So basically, it's on design 6, because I can't go up to 7. And so I have to back down to 6 to make this under 50. Okay. Okay, now we have another pattern that we're going to analyze here. And again, we have design 1, design 2, design 3, and design 4. It always helps to number these. Well, I'm already noticing here's a 4 by 4. So if I look right here, this is 1 squared. Whoops, I kind of cut that off. Sorry about that. This is 2 squared, 3 squared, and 4 squared. So first of all, I know the bottom section is going to be my design number squared. Okay? And then what I'm also noticing is this middle part here, right here, the middle, are just 2 blocks. And so the middle I can write as just a +2. I'm going to add 2 every time. It doesn't change, so I'm going to keep it the same. And then the top section here, if we look at our design, I'm trying to keep all this on the screen for you. The top is 1 row of 3, 2 rows of 3, 3 rows of 3, 4 rows of 3. So basically, it's 3 times our design up here, up top. So I'm going to do a +3D. And since we have a squared here, our design pattern is quadratic because of the d squared. And algebraically, I've got to find a different design. This is 2 expressions. So I'm going to come back up the top and look for a different design up here. Well, let's see what we can do here. Another design we can do is to rearrange blocks. I'm trying to figure out how to do this. So basically, if I pull this top section down like this, I basically move these 12 down. Okay, so I'm going to move these down. I'm going to shift this little top section. I'm going to add it to the bottom. And I'm going to add the top here to the bottom with those little dots. And here, I'm also going to add this top to the bottom. And then finally, I'll add this top to the bottom. So here's what we'll notice. First of all, this is 4 wide, but my length is 7. This one's 3 wide and my length is 6. This one's 2 wide and my length is 5. And this one is, let's see, 1 wide and it goes out 4. So I can see this pattern here of 1 by 4, 2 by 5, 3 by 6, 4 by 7. So first of all, I know I have my design, and then I'm going to add 3 to my design number, like this. And then I still have a +2 here. So I'm going to add 2. So all I did here was I moved these top blocks down, I added it to my bottom section, and I ended up getting these rectangles. So I have a rectangle like right here, and right here, and right here, and here. And these rectangles, the widths matched my design, but the lengths were 3 plus my design. So that's why I did d times d plus 3. It gives me the area of what's going on inside here. These 2 blocks stayed the same, just like in my other one, so I never counted my middle. So if I come down here, basically I want to see if d squared plus 3d plus 2 equals d times d plus 3 plus 2. Like this, sorry. And when I wrote that, I wasn't on the camera. So again, this is d squared plus 3d plus 2 right here. My second one with the rectangles was d times d plus 3 plus 2. And so if I multiply this out, I get d squared plus 3d plus 2. And we can see that that is equal to what's up here. So we basically proved that both the observations are correct. Okay. Our next page has a graph. And this is graphically show that the expressions are equivalent. So we want to graph these. Okay. And basically when I graphed it, it basically looked like this. I have a +2 here. And let's see what we have. We basically had a graph that kind of looked like this. And when I graphed both these on the calculator, you can see if I plug them in, and I'll do this in the y equals. Up at the top here, I've got x squared. Oops, that's the wrong thing. Let's clear that. X squared plus 3x and then plus 2. Now down here I'm going to type in my other expression, which was x, and I'm just substituting that for d, and that is parentheses x plus 3, close parentheses, plus 2. So when I graph these, I want to see they're the same. So let's go ahead and hit graph. And we see our graph goes down and up, and then another one comes along and you can't see the other. So see, there's the red one that's overriding. The best way to tell is to go to table, and if you go to the table of values right here, you can see that all the values are equal. So that graphically we're proving that these are the same function. Okay, number 3, yet another pattern. Now keep in mind your answer might be different than mine, and that's okay because there are a lot of different ways to observe this. But we want to identify 2 patterns. Well, the first pattern I see is basically this column like this. Like so. And then I've got my outside. Okay, so this column here is 1 by 5. This one is 2 by 6. This one is 3 by 7. And that's 4 by 8. So again, I can see that if I write my design numbers in here, like this, I could see that 1, 1, 2, 2, these all match up in my first dimension here. So I know that I got a D here, and now I want to multiply, but whatever this is growing by. Well, from 1 to 5 is 4, and 2 to 6 is 4. There's this pattern, 3 and 7, and 4 and 8. So I'm going to add 4. But then I have these sides. So I have 1 on each side that this matches my design number. So basically I'm going to kind of simplify this because I've got a D on this side. That's my design number 1. And I'm going to add another D over here. And see, I got 2, 2, 3, 3, 4, 4. So whatever my design number is, it matches that. So that's my first pattern. Now I'm going to use a different color for my next pattern so you can see what I'm doing. So I'll use blue. So what I'm going to try to do on this one, instead of going vertically, I'm going to go horizontally. So I'm going to look at, let's see, what's the best way to do this? I'm going to look at this right here and this. I'll make sure I draw this right so it's not confusing. And this right here. And then this one here. So now in the blue, still here I have a 1 by 3. Here I have a 2 by 4, so it's 2 by 4. Here I have 3 by 5, and here I have 4 by 6. So that's a little bit different pattern. So again, I have a D right here, 1, 2, 3, 4, 1, 2, 3, 4. So that's going to be a D. And I'm multiplying that times D plus 2. All of these are 2 apart. So if I'm my design number 1, I know it's going to be a 3. Add 2, get 4. Add 2, get 5. So I'm going to do D plus 2. So you can see that these look different. But now my top and bottoms are different. So here if it's 1, it's 4. Okay? So I'm just going to look at my whole pattern here. If I have 1, my answer is 4. Okay? And if I have 2, my answer is 8. If I have 3, it's 12, and 4, it's 16. Well, if I'm looking at this, I can see I'm multiplying by 4 every time. So I'm going to add a plus 4D. Because whatever the design number is, my top and bottom add up to that. So I'm just going to put a 4D. So those are my 2 patterns. And we want to describe this as either quadratic, exponential, or whatever. Well, we can see here, if I have a D times D, this is a D squared. Okay, so I'm going to go ahead and simplify this because on C, it's going to ask us to check. So over here I have d times d, and that's d squared. And d times 2 is 2d plus 4d. And here again I have d times d is, oh, let's use green. So switch my pens again. I have d squared over here plus 4d plus d plus d. Okay? So since we have a d squared, we know it's quadratic because of the square. Okay? So because the variable is squared. So that would be the reason it's quadratic on this right here. So as we go to the back, it says algebraically proved. So I'm going to take both these equations here. I've got this d squared 4d. So I've got d squared plus 4d plus d plus d. And then on my other one I had d squared. And let's look back at the blue here. This says plus 2d and 4d. So let's plug that in. So plus 2d and 4d. So if I'm combining like terms, the d squared stays by itself. We can't add anything to them. But here, these d's I can add up. So I have 4 plus 1 plus 1. So this one is d squared plus 6d. And we want to see if it's equal to this one. Well, here I have 2d plus 4d, so I have d squared plus 6d. So that checks. And that works out. So those are equivalent patterns. And then finally, we have number 4. And it says, analyze the pattern. It says, identify 2 expressions. So here we just want to find 2 expressions. And once again, I'm going to look for a square. So I'm going to start back here at 4. So we got 4, 3, 2, 1. And I can see a 4 by 4 right here. No, you know what? I don't like that. Let's look at the rectangle. I got a 4 by 5 here. So 4 by 5 right here. 4 by 5. Because I see a 3 by 4 right here. 3 by 4. And I see a 2 by 3 here. 2 by 3. And then remember, if I'm following a pattern, I want to make sure this one is 1 by 2. 1 by 2. Because these are all going down by 1. So first of all, what we have here is I have the design number times the design number plus 1. Because I'm going to add 1 to my column every time. Well, now all we have to do is count how many stars are on the outside of my boxes here. I've got 1, 2, 3, 4. 1, 2, 3, 4. Oh, all of these are 4. So all I have to do is add 4 here. Because I have 4 stars on the outside of my boxed out pattern every time. So that's one way to approach that. So if we need to find another one, because this has 2 expressions, I'm going to go back to my square idea. And I'm going to look at this 4 by 4 square. Let's use red. So I'm going to go red here. So here's 4 by 4, 3 by 3, 2 by 2, and 1 by 1. Okay? And then we want to look at the pattern outside the squares. So that is the design number squared. What I already circled in, and we got to look at the outside now. Well, it looks like I still have my plus 4. Do you see my plus 4 here? So all my ones on the outside are still plus 4. So I'm going to circle those like this. Here is my plus 4. So all of these are still plus 4. Plus 4. And then I have some left over here. Look what's left over. I've got 1, 2, 3, and 4. Well, that matches my design number. So I'm just going to add in a D, because here I'm adding 1 and adding 2 and adding 3 and adding 4. So every time my design number goes up, it matches exactly the number I'm adding. So we want to check and see if these are equivalent. So on the green, let's multiply out d squared plus d plus 4. And if I rearrange my red, I could switch out my 4 and d here because of the communicative property says like a plus b equals b plus a, or like 1 plus 2 equals 2 plus 1. So if I reverse those, I get an equivalent function. And that is it for test corrections.